Okay, welcome to your second lesson in the flipped classroom. So last time we were talking about the difference between scalars and vectors. Now we're going to get into some specific examples. All right, distance is one type of scalar, and displacement is its kind of sister vector. Okay, so distance, which we represent with the letter S. All right, so S is the variable that you'll see in an equation. All right, so whenever you see an S in an equation, that means that stands for distance or position. Okay, another way of thinking about that is position, so like where it is. Then this is scalar, so you don't have to include a direction, but what do you have to include? Hopefully you are saying unit. All right, everything has units. Then another way of kind of thinking about distance is it's the total distance that's traveled. Okay, when we start getting into a problem, we'll talk about this a little bit more, but because it's scalars, each distance, regardless of the direction, keeps adding on top of each other, so that's your total distance. You're probably much more familiar with dealing with distance than you are with working with displacement. All right, so displacement is represented by this delta, which means change in. So this is the Greek letter delta, which means change in, all right, or change in distance, right? And it's just we apply that Pythagorean theorem rule to figure out the displacement, all right? So the change from your starting point to your ending point, all right? So it's sometimes the path in between doesn't quite matter, okay? So another way of thinking about this, it's the distance and direction from the starting point, okay? So displacement's a vector, distance is a scalar. Let's try a problem, because you already know the rules for adding scalars and vectors, so we're going to do an example. So here's a trip. Susie's going to go 2 blocks east. What direction should the arrow be pointing? So you're saying to the right. Then she's going to go 1 block north, which is going to go up. All right, this is drawn relatively to scale. 1 block west, point to the left, and north, and 1 more block north. She wasn't ready yet to stop. Okay, so we have 2 blocks, 1 block, 1 block, 1 block, and 1 block. All right, so block is our unit, so to speak. Find the distance and draw the displacement of Susie's trip. Okay, so what I want you to do, pause this for a second and see if you can do this on your own. Draw it out on your paper, and then when we turn the video back on, see if what you have is the same as what I have. Okay, so distance, I'm going to use our new variables. Our distance is going to be just adding all of our blocks together. So it's 1 plus 1 plus 1 plus 1 plus 2, which is equal to, hopefully you said, 6 blocks. All right. Now your displacement is going to be from your starting point down here to your ending point, or the open tail to the open head. So your displacement line should look something like this. Okay. So I'm going to flip to another slide, a clean picture to work with, and there is our displacement drawn. All right. So now let's actually find, and I know our little slide here doesn't say to actually do this, but let's find Susie's displacement. Okay. So first glance, it doesn't look like we have a right triangle to work with. But let's add in another line here. Let's draw this straight down, make a right angle. All right. Now, this line, this red line, should be how many blocks long? If you notice, it's the same size as this line. And how many line was that long? So that's 1 block. Alright, here's one block, and here's one block. Now we knew this whole thing was 2 blocks, so what's it going to be right here? Again, this was 1 block, which means this part here is 1 block, and I just did that backwards, block. So what's left is 1 block. Alright, so where do we go from here? Now that we have a triangle, which we know is 1, 2, 3 blocks high, so 3 blocks by 1 block. And we have a right triangle. Hopefully you are saying the Pythagorean theorem. Alright, so we have our a squared plus b squared equals c squared equation. If we make this a, this b, and this c, we're going to have 1 squared plus 3 squared equals c squared, or 1 plus 4 equals c squared, or 5 equals c squared. Alright, and then based on that, what should we be doing next? Sorry about the crack in my voice there. Hopefully you are saying that we need to get that down to just plain c to know the length of our resultant. So we need to take the square root of 5. Alright, so square this side, square that side. C equals 2.2 blocks. Am I done? Hopefully you are yelling at me no, because what am I missing? Our direction. So again, if you look at our resultant, we are pointing up in this direction, which is north and east. So northeast. So there is your displacement. Okay? So, very simple transfer of adding scalars and vectors to applying it to actual real values that you're going to work with quite a bit in physics class. So, make sure you have some notes with you tomorrow. Make sure you do the online assignment and be ready for your quiz. I'll see you in class.